guys, welcome back to my channel, Subject-o-Phile. This is Utishman Dhar here, and I will be trying to solve some innovative and interesting questions, just like as I mentioned in my first video. Uh, the questions can be from any subjects catering to physics, chemistry, mathematics, and biology of the level of class 11th and 12th. And I would be trying to help you guys excel in your competitive exams. The questions will be of that level so that you can think beyond and enable yourself to do well in those exams and tackle the most difficult and challenging questions with the right concepts. I know the second video is coming a little late than the third video, than the first videos, than the first video, but I'm sure that the third video after which will be coming after this would not be so late, just like the second video. And without any further delay, let's get into this question. This is actually basically a mathematics question, which is actually, using the idea of inequalities. Today, we will going to understand and deal with very common inequalities that we generally see in the syllabus of 11th and 12th. So let me read the question for you. It says if x, y, and z are real numbers from the interval 0, comma root 5. That means that xyz lies between 0 and root 5 such that xyz equals to 1. Prove that. So a, a thing is given which is x by 5 minus y square plus y by 5 minus z square plus z by 5 minus x square has to be greater than equal to 3 by 4. So let's get into the solution. Just like as I mentioned in the previous video, that for each and every question that I'm going to solve, I'm going to provide you with the concept behind that question and the thinking process that we would generally require in such question. Okay, the first of all, when we see that x, y, z are positive real numbers, the first thing that comes to our mind when we see questions of inequalities is the use of a very common inequality that we all know, which is the AMGM inequality. So now let me just broaden the inequality a little bit with two new terms which you all know, but just in we am writing the general inequality that we will use for solving this question. Here it says for any positive real numbers a1, a2, a3 dot up to an. So there are n real numbers, positive real numbers. Then their quadratic mean has to be greater than equal to arithmetic mean, which will be again greater than equal to geometric mean, and finally greater than equal to harmonic mean. Now, what is the quadratic mean? It's nothing but the famous term which we use in physics, also chemistry. Also, we have learned root means square, right? Root means square speed. So it's a statistical term which actually denotes which we also call as quadratic mean. It actually denotes this, which is the square of the variables, uh, taking the average of the square of the observations, and then putting a root over under the entire thing. That is our quadratic mean. So that has to be greater than equal to the arithmetic mean, and which is again greater than equal to the geometric mean of the n positive in real numbers, and then it is again greater than equal to the harmonic mean of the positive n real numbers. So symbolically, we can represent this like this, that we can easily represent it like this, right? So okay, I missed a bracket here. I'm sorry. Okay, yeah, yeah. So we can represent it like this. Now, obviously, we can easily say from observation that equality will hold if and only if this is actually if and only if a1 equal to a2 equal to a3 equal to an. So only if all these n positive real numbers are equal to each other, then and only we can say this equality for each of these signs, equality will only hold if this condition is satisfied. Okay, so using this concept, this entire thing that we learned at the beginning, we will apply this into this question get the proper proof of how that thing which is being written in the question is greater than equal to 3 by 4. So, okay, uh, see, x, y, z, x, y, z are all positive because it lies between 0 and root 5. So, all these terms should also be positive, obviously, because 5 minus x square, 5 minus z square, 5 minus y square will be positive since y is less than, all these terms are less than root 5. So, this the denominator will be positive, and obviously the numerator is already positive as we have mentioned. So, this entire thing is also positive, right? So now for positive, since these are positive real numbers, we can think this as a real number a1, a2, and a3. Then we can apply the AMG and GM inequality in this, stating that, okay, this is a1, this is a2, and this is a3. So a1 plus a2 plus a3 by 3 has to be greater than equal to cube root of a1 into a2 into a3, right? So now xyz, in it has been already given in the question that xyz is equals to 1. So we put 1 here, and okay, then see, it is very tenuous to write this entire thing every time. So let us assume that this entire thing which we need to find is, say, s. Okay, so s by 3 will be greater than equal to cube root of this thing, 1 by 5 minus y square, 5 minus z square by 5 minus x square. Now, let us say this is equation 1. Okay. Now, what happens is, since we know x, y, z lies between 0 and root 5 as given in the question, then 5 minus y square, 5 minus z square, and 5 minus x square are positive. We have already said that since all these are all less than root 5, so its square will be less than 5. So these terms are positive. So, since 5 minus y square, 5 minus z square, 5 minus x square is positive, then we can easily say that its reciprocal, which is 1 by 5 minus y square, 1 by 5 minus z square, and 1 by 5 minus x square, it will also be positive. So, considering those as another set of positive real numbers, let us say b1, b2, and b3, we can apply the GM-HM inequality, or geometric mean and harmonic mean inequality, sorry. So it would be cube root b1 into b2 into b3, which is 1 by 5 minus y square into 1 by 5 minus z square into 1 by 5 minus x square, which has to be greater than equal to 3 by 1 by b1 plus 1 by b2 plus 1 by b3. Now, since b1 is again 1 by 5 minus y square, b2 is 1 by 5 minus z square, and b3 is 1 by 5 minus x square. So, basically, if we solve this, then we will get that it will be cube root 1 by 5 minus y square into 5 minus z square into 5 minus x square greater than equal to 3 by, this all will come at the top, like this entire thing would actually become 5 minus y square. This entire thing would actually become 5 minus z square. This entire thing will actually become 5 minus x square. So if we add all those, then we will get 15 minus x square plus y square plus z square. Now from where this thing came, right? So this thing actually came, see, it is written that it came from the equation 1, because this entire thing, as we already wrote, is less than s by 3. See, we already wrote in equation 1, right? So this thing came from here, from equation 1. So s by 3 is greater than this thing. So obviously s by 3 is also greater than this thing, right? Now, now let us say, consider the numbers x, y, z, which is already given in the question, which are positive real numbers. Then we can say that for these three positive real numbers, we can obviously apply the quadratic mean and geometric mean inequality, which is root over x square plus y square plus z square by 3 greater than equal to cube root of x, y, z. Now, again, it is already mentioned in the question that x, y, z is equals to 1, right? X, y, z is 1. So this become 1. So this entire thing also 1, right? This entire thing also becomes 1. So we can shift the root 3 here and we can square the both side to get x square plus y square plus z square is basically greater than equal to 3. So let us say that this is equation number 3 and we already mentioned that this is equation number 2. So now we can use equation 3, which is equation 3 in equation number 2, right? You can see we have this thing x squared plus y squared plus z squared. So to carry on this further, to simplify this inequality further, we need to have a basic idea about the boundaries of x squared plus y squared plus z squared, right? So here we can get the we can get the boundary, right? Like x squared plus y squared plus z squared has a minimum value of 3. So this is our bound. So from this we can clearly write that 15 minus x 15 minus x squared plus y squared plus z squared will definitely be less than 12, less than or equal to 12, right? So if we take reciprocal on both sides, then it will become 1 by 15 minus x squared plus y squared plus z squared is greater than equal to 1 by 12. So basically we can use this thing now here, which is in equation 2. Right, we can now use this thing here in equation 2 because we knew that in equation 2 it said s by 3 is greater than equal to 3 by 15 minus x squared plus y squared plus z squared. Now you know 1 by 15 minus x squared plus y squared plus z squared is greater than equal to 12, 1 by 12, sorry, greater than equal to 1 by 12. So this thing right here has to be greater than equal to 3 by 12, right? 3 by 12. So this thing has to be greater than equal to 3 by 12. So we can indirectly say that s by 3 is greater than equal to 3 by 15 minus x squared plus y squared plus z squared, which came from our second equation, right? Second equation. So from second equation we got that. Now we can replace this entire thing from this equation. We can replace the entire inequality from this inequality, and we can say that s by 3 is greater than equal to 3 by 12. Since s by 3 is greater than equal to 3 by 12, then we can easily say s greater than equal to 3 by 4. And we know what is s. We assumed s as the thing which we need to find in the question, which is x by 5 minus y squared plus y by 5 minus z squared plus z by 5 minus x squared, which we can say finally that it is greater than equal to 3 by 4. So it is proved, right? So we just used the same concept over like three different set of variables to get the solution. So what was important in this question was to identify which is our positive real numbers a1, a2, a3, an. Right? Though here we have only used three variables, but I am saying that what is important that you have to try to identify that what would be those a1, a2, and a3 that we are going to use here, right? At the first inequality, the first AMGM inequality, we used a1 as x by 5 minus y squared, right? We use these as a1, a2, and a3. But in the second inequality, GMHM inequality, we used a1 as 1 by 5 minus y square, 1 by 5 minus z square as a2, and a3 as 1 by 5 minus x square, right? So we are changing, basically we were solving the same question, but we were changing the variables, right? A1, A2, A3 was different in each and every inequality. And then we were forming certain inequalities and equations to get the final result or the final proof which we require. So even in this GM inequality, we used a1 as x, a2 as y, and a3 as z. So finally we appear at the result which we need to prove. All right. So this is our answer to this question. Now, since we learned this concept today, I would like all of you guys to try and practice a homework question that I'm giving you now, which I'm reading the question for you, which says if a comma b comma c are three positive real numbers, then prove that a square plus 1 by b plus c plus b square plus 1 by c plus a plus c square plus 1 by a plus b is greater than equal to 3. So this is also a very simple proof. if you can easily apply, if you can apply whatever has been taught today to you, the inequalities, how we can use it, and how we can you know, how we can manipulate the inequations to finally get our result, then you can easily solve that. Even if like if you have even after this, if you have problem in solving this, then you can obviously contact me in the Telegram group that have that the link which I have already provided in the last video. Even and still I will provide it in the description today for you all, for all of you guys, so that you can easily access the Telegram group and join there to further to post your doubts further, and to also post some very good questions which might be taken up and selected for the next video. Who knows, right? So, thank you guys. Thank you for watching this video. If you have liked the solution to this question, if you have liked this video, please uh, like, please share and subscribe my channel. It would be really helpful for me, and it would also provide me with the with the required motivation to carry on the aim of helping you guys through the videos that I post in my YouTube channel. Thank you.